Thank you all for joining us today and welcome to this webinar, Value of Centralized Secure Disturbance Record Collection and Analytics. I'm pleased to introduce today's speaker, Mr. Fahid, KA. Fahid is an AVP responsible for product management and global pre-sales of Calkitex Sync products. He has extensive expertise in utility protocols and has worked with utilities around the world in helping them build automatic fault collection and analysis systems that meet their requirements. The presentation will approximately be about 45 minutes, and questions will be answered at the end. Attendees are requested to submit questions to Fahid using the chat box. Should we not have time to address all questions, Fahid will follow up with you individually after the webinar. So without any further ado, I'd like to turn it over to Mr. Fahid. Fahid, over to you.
Thank you. Yes. About value of centralized disturbance collection, its analysis, and configuration management from the center. Regarding today's topic, so we move on to some of the native architecture. What are the problems with the native architecture? What are the new architecture we are proposing? Advantages of new architecture, its use cases, various components involved in the new architecture. What are the different standards involved in the disturbance collection system? How we can do a simultaneous access, that is disturbance and data collection together with the configuration management through a single port. Then redundancy handling, various redundancy requirements of the system in the system level as well as on the network level. Then how the configuration can be done from the central system, security requirements of the system, hardware requirements, and some of the case studies in which we have provided a solution to various customers across the globe. So that is a brief overview of what we are covering today. Moving on to legacy architecture for disturbance collection and IED parameterization or configuration. In the legacy architecture, there will be multiple vendor IEDs, and that vendor IEDs will be controlled by separate vendor system, or we call it as separate protocol gateways. So multiple vendor IEDs having multiple protocol, and there are dedicated protocol conversion gateway or a centralized dedicated system for each vendor IEDs. Then because each vendor manages their own IEDs using a system, a centralized approach managing all the IEDs together from the center become nearly impossible. So this is the overview architecture of what we have in the substation as of now. Now, shortcomings of the legacy approach. So there are multiple IEDs, multiple protocols involved, and multiple formats for the disturbance collection. So collecting all the disturbance and analyzing it at the center without using a vendor tool has become nearly impossible in the legacy approach. Then configuration management, it is completely dependent upon the vendor tool, and these tools are having again version dependency with the IED versions, and managing each IEDs launching corresponding tools manually becomes a tedious process, and automation and other configuration management has become very difficult using the legacy approach. Then most of the IEDs are having a single port connected to the IEDs. So managing the configuration and data retrieval or DR retrieval together used from the same port became the same port is not possible at all. Then strong cyber security requirement as per NetSIP standards and role-based access, etc., are not possible in the legacy. Then preserving settings, redundancy mechanism, preserving the network setting, etc., become problematic in the legacy approach. So these are some of the shortcomings in the legacy approach. Now we move on to a centralized approach for the disturbance collection and IED parameters. So in this, again, there are multiple IEDs and each vendor dependent IEDs are there in the field. But all these IEDs are connected to a redundant protocol gateway or data concentrator, which is used to collect the live data from all the IEDs plus a disturbance record from all the IEDs in its protocol. So this gateway should support all the protocol that is available in the substation, which is supporting multi-vendor protocols for the data collection as well as the disturbance collection scenario. Once the disturbance records are collected in the data concentrator or protocol converter, we call it a sync 3000. The same file, the disturbance file, can be in multiple format that is converted into a IEEE standard format, which we call it as COMTRADE, within the device itself, and it is stored within the device. And whenever there is a new file available in the device, it's pushed to the central system, and in the central system, the user will be able to define the folder structure or a hierarchical structure in which the availability of files depending upon the feeder will be available. And on the central system, there is an automatic fault analysis application running on specific set of file, can do the analysis and throw what are the causes for this disturbance record and what are the corrective actions needed, can be analyzed sitting at the center, because all the files are converted into a common format now, COMTRADE, which can be analyzed by any of the tool which is supporting a standard COMTRADE file. And also there is a centralized, that is server client based system for the configuration management. So there will be a hierarchical representation of complete electrical hierarchy and up to a feeder level hierarchical representation. And from the feeder, user will be able to launch the corresponding tool, and the versions of the different configuration file will be available for the user. And using the latest version or a prior version, user can do the settings download to the relay sitting at the central location, or a client machine which is linked to the central location. User can do complete setting download to the corresponding IEDs. So in short, there are redundant gateways so that there is no single point of failure will not be affecting the system. So we have redundant gateway supporting all the protocol. And if there is a requirement, so in the redundant gateway itself, using the single port connected to the IEDs, these gateways can collect the live data, and also using the pass-through functionality, pass the configuration messages to the corresponding IEDs using the single port itself. But if there is a requirement for the utility to have a separate mechanism, that is a separate port for the DR collection and live data collection, and a separate port for the configuration management, that is front port for the configuration management. That can also be done using the terminal servers connected on the front port of the relay, but this is not a mandatory case at all. So if there is a requirement, there can be an optional port for the configuration. Then centralized device management software is available at the center, which manages the configuration sitting at the center or client machine connected to the central system. Then there is a end-to-end security. So we have a dedicated tunnel between multiple substation and control center using TLS 1.2 encryption mechanism, and we support all the role-based access. So different users, its user group can be created based upon the roles assigned to the group, and under the user group, multiple users can be created under the user group. So role-based access can be there, and all the certificate, everything is managed in all the substation. So certificate validity and all other things can be checked, so that any revocation of access, anything is needed, that can be managed using the central approach. So this is the overview of the centralized approach. Now we move on to DR collection and IED parameterization. What are the different components of the centralized approach? First component is secure substation gateway. So it enables the disturbance collection in any of the vendor IEDs using multiple protocol drivers available, and we have around 40 plus protocol drivers which is dedicated for the disturbance record collection, and it collects the disturbance record in vendor format itself. So vendor format can be multiple, like if a cell relay is used, the cell format is available, which is again ComTrade format is preserved in cell itself. If it is a Siemens relay, then if the protocol supported is 103, then 103 has got specific format. And if it is ABB system, they have a Rival format over the SPA protocol. If there is Alstom or Arriva system, there can be courier format, which is representing the disturbance record as well as the protocol transmission. Also, there are custom mechanism like GE Modbus. So GE relays use their own customized Modbus protocol for DR collection, and its representation of data in a specific format. So we support all those type. So whatever most probable DR collection format as well as protocols available for the DR collection, we support all. So from multiple vendors, we can gather the disturbance record in its format itself. Then this gateway again converts this custom DR format to a common format named ComTrade format, and its file representation, naming convention, everything is supported as per the standard. Then whenever there is a new file, that is ComTrade file is available, we use a secure FTP tunnel over the TLS 1.2 and push this to the central system using the configured hierarchical, depending upon the utility requirement, the hierarchical folder structures. Using that, this is automatically pushed to either to the central system or multiple system, like there can be a regional control center as well as a centralized control center. You can push this file to all those systems over. And we have a complete hot standby or hot configuration for the avoiding single point of failure, and also need to have a PRP XSR protocol for having a network redundancy. So we support a PRP HSR protocol for seamless network redundancy requirement, so that any network failure happens, the complete data is always routed through two separate networks. So even though there is one network failure, the data is ensured to reach the destination bumplessly. So that is one of the key advantage in having the network redundancy using PRP HSR. Then in the solution, there is a centralized device management software. We call it as a power system enterprise suite, or in short, PSCS software. So that represent the complete electrical hierarchy, and up to the feeder level it represent, and it indicate which all are the devices that is communicating successfully, which are not communicating, using the SNMP protocol available, and using from the feeder it can launch the corresponding tool which is linked to the IEDs, and this tool can be presented with the latest configuration file. And if a user want to see an earlier file and compare it with the earlier file, that can also be done using the same. Then end-to-end security is ensured. This is the substation to center is again through a TLS 1.2 tunnel, and also we have role-based access control, and if there is a live data transfer is needed, we support 62351 based DNP3 secure authentication. So all those secure mechanisms needed to support the complete connectivity, and a system level security as per the NERC 5.0 standards, we support that also onto the complete system. Record collection system. So as key use cases under the disturbance collection is, again, the disturbance collection using multiple protocols from multiple devices, data conversion from the DR format to the contract format, then data to central system using file transfer protocol, host standby, and PRP HSR support for coding network losses. Then another key feature is simultaneous access. So we in the gateways, the support needed is a transparent or pass-through channel. So whenever there is a config, this ensures a tunnel from the sync 3000 to the end central system or a client system where the vendor tools are running, and there is a tunnel ensured between the IEDs to the system, and using this tunnel user can do the configuration. And this, if there is only single port available in the relay, that port can be shared between the DR collection as well as the configuration management. So whenever we have a configuration mechanism to which user can decide whether the configuration need to go through whenever there is a configuration file available, whether it need to do the configuration fully, temporarily stopping the DR, or do a using a cycle stealing approach in which a DR request is transmitted, and in between there will be configuration request also. But most of the utility prefer to have a temporary stoppage of DR when the configuration file is downloaded to the system. Then another key use case is many utilities have their network settings for a substation, and which is again not unique when viewed from the center. So one substation having an IPA will be maybe getting repeated on another substation. So connecting from the center and configuring it onto the IEDs using the same IP will not be possible from the central approach, central side. So in that case, what we provide is a NAT support in the gateways, which we call it as a network address translation support in the gateways, in which there is dedicated IPs for the access of the system from the center, and these IPs are forwarded onto the already used IPs in the substation. So this is automatically taken care once this is configured for NAT. So complete utility can preserve the existing setting and do the complete configuration without bothering about any of the systems. So this is a zoom-in view of the complete architecture, in which this is the protocol gateway with multiple protocol drivers, and each relay or even loggers are connected to that using a specific protocol, and we collect the live data, and this live data can be sent to any central system using other protocols that can be mapped to other protocol like 104 or DNP3, and we support a secure DNP3 with the secure authentication also. And it can also collect the disturbance data, and this can be converted. This will be converted onto the ComTrade file, that is IEEE standard, and these files are available onto the system, and this file will be pushed to the central system using a TLS 1.2 tunnel between the substations and central system. On this central system, this file will be present in the pre-designed folder structures, on which an automatic fault analysis tool, this can be a third-party tool if you want an enhanced analysis, or we have a minimal analysis supported in the remote accessibility system, or we call it as a PSCS system. So this tool, any third-party tool can do the analysis on this ComTrade file and throw what are the causes for this disturbance record and what are the preventive actions. Plus live data, if we want to monitor, that can be this Sync 4000 also support ICCP and other protocol, and it can be sent to the other control center, and actions can be performed from other control center to the Sync 4000 and up to the relays. These actions can be performed. And this remote accessibility system, or we call it as a PSCS system, is having a server client architecture. So this will be having a server system, and multiple client can be there in the multiple system. And depending upon the role-based access, each substation will be, or substation or region will be permitted to a set of users, and that user will only be able to access that region and configuring that region. So that can be done sitting on his own laptop and connected via the server system and moving on to the corresponding relays. So this is the overview of the architecture, and that can be a main system and backup system as well, and we can synchronize between main system as well as backup system. We can send this FTP and live data to multiple systems as well. Then moving on to different disturbance record format supported. So you are already aware of ComTrade format, which is the standard format, which is having header, configuration, DAT, information elements, and configuration and DAT files are mandatory. I'm not going into the details. And 61850 uses the ComTrade format directly, and IEC 103 has got its own format, and that is specified in the standard. And other formats are available, like SPA has got a Rival format, and Alstom Courier Relays has got a compressed courier format. there are multiple vendor format like GE Modbus format, and a protocol and format widely used in South America is Procom protocol format, and we support all these types. And this is regarding the simultaneous access. So consider, for example, there is only single port for the relay, and we want to take the live data from this port as well as disturbance record through this port, and also need to have configuration management through that port. So we have a protocol Y in the relay, and this is sync, that is protocol gateway, and it will be having a master protocol Y master, and it will be collecting the live data, converting it to a DNP3 or any other protocol, and sending it to the central system for live data transfer. On this protocol, Y driver also will collect the disturbance based upon the periods configured, or if the protocol support event-based disturbance transfer, that disturbance file also will be collected by the protocol. Now, this Y can be associated with a transparent channel, which is linked to the parameterizing software, either through a TCP channel or a serial channel. And then once this parameterization software gets connected to this channel, the data will be available onto this channel, and this protocol Y master will be temporarily stored and allow the messages from the transparent channel to the pass through the same port, and the response back to the parameterization software. This way, using the single port, we will be able to manage live data collection, disturbance record collection, as well as configuration management. If the relay has got two ports, then we can dedicate one for the live data and disturbance and other for the configuration. So this transparent or pass-through channel is enabling us the simultaneous data access for communication as well as for the configuration. Then redundancy, we support both hot standby, and it also has got hot cases, and network redundancy mechanism. So switchover, we have a hot standby or hot configuration, and the switchover can be detected by itself. We call it a self switchover, or an external SCADA or a centralized system can issue an external command on the switchover point to trigger the switchover, and mix of both self switchover and external triggered switchovers are supported. And IP management scheme, we have fixed IPs for both the redundant gateways, and also have a dedicated hot IP and a dedicated standby IP. So whichever gateway turning into hot, that corresponding hot IP will be allocated to that gateway, and whichever gateway is turning to a standby, that standby IPs will be allocated to that standby gate. In this mechanism, will allow the centralized SCADA system or any other system to always connect using hot IP, irrespective of which gateway is turning hot, which gateway is turning standby. The application need not be aware of that. It need to just connect using hot IP, and it will be getting the details. It will be getting all the live data and all other stuff. Then health status count. So there is a dedicated link between the hot and standby gateway, and heartbeat is always exchanged between both the gateways, and health status count is calculated intelligently depending upon the number of nodes online, number of channels working, and this health status count is always transferred to the standby gateway. And whenever the standby gateway takes turns into hot, it compares the present healthiness status with the previous hot gateway healthiness status, and if there is the present gateway has got a better health, or a equal health, it will be continuing in the hot status itself. If the health is less, then it will be switching back to the previous state. In this mechanism, the advantage is that this mechanism intelligently prevents the switch back, switch forth mechanism. Instead, it will stick on to the corresponding state as long as the state gets preserved there. And we support an SNMP manager on all, SNMP agent on all the gateways, and SNMP manager on the PSCS. So all the gateway status and as well as the feeder relay communication status, everything can be monitored over the SNMP. And for network redundancy support, the PRP HSR protocol is supported, and it ensures that there is bumpless data, even though there is a single network gets failed. It ensures that the data gets always gets routed through the alternate route also, and both the data will be available if both the networks are working. And if any network fails, the other data through the other network will be available. Now moving on to the centralized IAD management. So is actually having a centralized system in which user can have a client server architecture, in which sitting at the client system, it can launch the corresponding tool depending upon the which feeder is going to configure, and the tool will be provided with the latest configuration file, and sitting at the center itself, this configuration file can be downloaded onto the end relay. And this also support multiple versions of the configuration vendor relays, enabling the management from the central system itself. It also has got a database containing all the latest configuration file. The history of the configuration files are preserved, and it provides a detailed mechanism of version management. And disturbance record viewer, disturbance record collection, all the systems are supported, and preliminary analysis functions are also supported. And if detailed analysis is needed, this tool, any other tool can be linked with the PSCS tool to do a detailed analysis and throw the reports. Key features include tool-based configuration management sitting at the center. Then there is a remote access through the TCP network. Then hierarchical representation of the complete electrical network over the web. Then detailed user management, role-based access management, and it support Windows as well as web clients, and support Linux for the server, that is PSCS server. Then there is a Google Map integration is already available. So sitting on the complete Google Map, you will be able to see which are the location that is communicating properly, which are the location that is not communicating properly, that can be moved. And it also supports SNMP, as I indicated earlier, and all the status can be monitored used through the PSCS tool, or any SNMP manager can be used to view the complete system. Another feature is detailed audit trail based upon the user and its privileges are available, and that can be tracked into detail. Then alarm categories, different alarm categories can be configured depending upon the categories. This can be viewed on the web interface. There is a DR download feature is there, which from the server to the client system it can download. Plus, it can view a specific DRs within the specific timeline and do the analysis based upon the timeline. It can trigger a detailed analysis and save it as a incident based report. It can save it as an incident report and can be viewed later with the incident number or a timeline in which that incident has occurred. So these are some of the key features of centralized IAD management. Got a thick client which is Windows installable, and a thin client which is a web client. Both are supported. So here you can see centralized location, and you can see multiple region like northern region, eastern region, southern region, western region, and under each region you can have multiple substation and under substation you can have multiple feeder, and under the feeder you can have multiple single or multiple IEDs are available. And substation, you have a representation of Sync 3000 there, or a substation gateway there, and its status is monitored, and this is using the SNMP message transfer. We are getting it lively communicating status or a failure. So here you can see the failure. This is live communication status. Same is obtained for the IEDs as well. So if you select the corresponding feeder IED, you can have a launch tool. So once you click on the launch tool, the cell configuration tool like accelerator will be loaded, and that will be provided with the latest configuration file. And you can when the latest configuration file is retrieved, you can archive the configuration to the database or retrieve the configuration file, any version from the database. All those things are available in the tools. Also, fault analysis packages. So some of the package is inbuilt with the PSES itself, and a detailed analysis package. Any other third-party package can be linked onto this. So these are some of the features supported by the analysis package in principle. I'm not going into the details of it. Then moving on to security requirement, one of the key requirement is NetSIP 5.0 compliance, and as well as a guideline based upon the IEEE 1686, that is for the security compliance for the intelligent electronic devices. So some of the guidelines they are put, and what are the what we are fulfilling as per the guidelines. We have a document publishing the same. So this is already available, and we also support a detailed user management and a role-based access control. So different user roles, privileges, everything can be assigned, and roles can be clubbed together to create multiple user group, and you can have multiple users under the user group to manage this. And we also support a open VPN and also a secure tunnel based upon the 1.2 TLS 1.2 based tunnel. So earlier we used to give it based upon the open VPN, and now we are transferring it to TLS 1.2 tunnel, and we are updating it in the latest releases. We will be updating it with the 1.3 TLS 1.3 features as well. So we have a complete software package, that is 62351 is the basic guideline, and the certificate exchange mechanism is there, and that is using X509 based certificate, and simple certificate exchange protocol is used for exchanging the certificate, and validity check and OCSP protocol is used for the validity check of the same, and different authentication hash algorithms and cipher suites are used for encryption mechanism. So this all the encryption mechanism as per the 62351 is covered in the complete substation 2. So it is a complete end-to-end security we are targeting with this solution. Then moving on to Calcitech, some of the customer case studies in which Calcitech is involved. Is with the REN Portugal, that is the transmission system in REN, and distribution, that is sub-transmission and distribution system based upon the EDF. EDP is the utility in the Portugal, and we have our partner named Info Control for providing the complete solution. So in REN, what we provided is Sync 3000 based architecture. In the all the substation will have Sync 3000, and there are relays from ABB, Alstom, Siemens, and GE. And there were pilots installed for in 5 substations to have a DR collection and a centralized management, and that is getting now, after successful pilot, it is now implemented in 55 substations. And in the EDP, which is a sub-transmission and distribution system, the same system is in place. Plus another thing is, from the ComTrade file, we calculate the loop impedance value from the ComTrade file, and using the GIS tool, we transfer this loop impedance value to the central system. Central system has got a GIS mapping, in which this loop impedance can be superimposed over the impedance of the lines and detect in which are the possible branches, which are the possible areas on which this fault may have occurred. So their target was within 10% of accuracy, and we could achieve within 5% of accuracy itself. And on their evaluation, a third fault caused in a EDP substation recovers their cost for the complete purchase and deployment, everything. So after evaluating in 10 substation, they are now put the same in implemented the same around 150 substations in EDP, and they have presented the same paper in a paper related to this in the distribution events named CERT in 2013 as well as 2015. So Greece, it is a Thailand substation, and they needed a DR collection as well as records and event information extracted from the DR records, and they want a role-based access, audit trail, alarm, event data, and report generation. First target was 1 substation, then they moved on to 5 substation, implemented it over 5 substation. Now they have added 1 more substation, taking it total to 6. Now they will be adding more substation, and this include protocol like 103, CEL 61850, and GE models. And one of the other pilot we are doing is in the national grid. So we have demonstrated successfully. Initial evaluation is over, and they are planning to have a pilot based upon that. Siemens 103, ABB SPA, Alstom 61850 relay, and they also want a protection management system in which automatic retrieval is needed from the rather than manual retrieval, which we have done in other project. They want an automatic configuration retrieval from retrieval from IADs at a fixed time, and they want that to be compared with the master file, and if there are any changes, they want to throw the alarms. So this pilot is expected by the end of 2018 financial year or start of 2019 financial. And one of the key projects which we have done in India is for the transmission asset management system. So this is for the Power Grid Corporation of India Limited, which is one of the largest transmission utility, covering 95,000 kilometers, including 2.5 million square kilometer area. And it involves disturbance collection, even log from various IADs, and wanted to download it to central system through multiple regional asset management center. They need to have complete view, configure the device, collect the disturbance and event data and making the complete transmission substation unmanned. This involves 300 substation, and all the substation need to have redundant system and around more than 3000 relays, and involving around more than 60 different relay models, and it is one of the largest asset monitoring project in a transmission network. So this is on the power set. This is completely deployed in India. So this covers details on the solution. Now we move on to some of the questions just put forward. So let's check the questions. So one of the questions that has come up is we have a centralized approach. So in the substations, we already have a terminal server to convert the data in the substation. So can we have a centralized approach? So that is a question. Quickly move on to that corresponding slide. So this is the architecture which is proposed now. So this proposes a Sync 3000 at each substation and collecting the data through Sync 3000 and sending it to the center, which is having Sync 4000. So question is, they have a terminal server situated at the substation, and they are already taking the serial to TCP conversion and sending this data to central. Then can we have a centralized approach to collect the data disturbance and configuration? Yes, we can do that. Definitely this architecture support a centralized approach also, but it is not only the DR collection which we are managing with the substation to the center approach using substation gateway, but the complete security between the center to substation and even role-based access, all those password management, all those stuffs are getting managed through the complete system. So even though we recommend Sync 3000 at substation level, we are flexible on the architecture, and that can be done only using the Sync 4000. And we have a multiple customer requirement also regarding this, and we have proposed it based upon the centralized approach itself. Okay, another question is whether we do an upsampling or downsampling for the DR collection. No, we are not doing any upsampling or downsampling in the Sync 3000. We are collecting the disturbance records in its vendor format as per the sample rate supported in the IEDs, and we are transferring, just converting it into computed and transferring it to central system. And central system software, that is AFA software, can do upsampling or downsampling on the DR files. Okay, another question that has come up is, what are the typical time period of the project of this type? That varies. So for deploying 55 substations in Portugal, they took almost 1 year timeline to complete the 55 substation setup and data, collecting the data in the disturbance record and configuring from the centralized system, managing the stuff. So in Indian scenario, it is around 200 substation. So entire project took around almost more than 2 years for Indian scenario to complete. So there are different approaches. In India, this was a tender based. After demonstration, it was a complete tender based order. in Portugal. They have deployed it on a pilot basis and ensured all the things are working fine. Then moved on to the moved on to final purchase involving multiple systems. So there are different approaches for that also. Okay, another question is automatic config download scheduling, how the same is achieved. So what we do is that in the centralized tool, there can be manually you can launch the tool, and also that has a provision to give a automatic scripting associated with the automatic download, and it can give a cyclic period or a fixed timeline of the day or multiple timeline of the day to trigger it automatically during this interval and collect this data. So we are doing this approach for automatic download approach based upon National Grid project, and we are doing one by one relay types, and now we are focused on cell relay types, and we have completed almost all many models in the cell relay which are available with us, and we will be migrating to other model as well on the automatic DR collection scenario. Okay, and another question that has come up is in the pass-through channel, how the priority is decided on the pass-through and main channel. Okay. So moving on to the pass-through. Configurable options. One is pass-through having highest priority. So if user configures highest priority for the pass-through channel, if there are any messages on the pass-through channel, the main channel will be blocked temporarily for the timeout period, and this will be processed and reply will be sent. Next transparent channel request will be processed and reply will be sent. So that is if the highest priority is put for the transparent channel. If normal priority is put for the transparent channel, it goes in a cycle stealing approach. That is one main channel message getting processed. Then it will check whether there is any messages on transparent channel. Then if there are messages, that message will be processed. Its reply will be sent. The next message of the main channel will be sent. Its reply will be sent. Then it checks there are any messages in the transparent channel. If there are messages, it will be taken and sent. The reply will be sent like that. So this is based upon the cycle stealing. That is the master channel will work, and some of the times it will be allocated in between for the transparent channel. So these are two mechanisms, but vendor prefer, most of the utility prefer the transparent channel having highest priority method, because the configuration happens very rarely, and when the configuration happens, they are okay temporarily halting the main channel and let the configuration gets completed fully and then process the main channel. If there are two separate ports, then this case will not come up, because this can be parallelly done. That is, main channel data as well as disturbance can be retrieved through one port, and the transparent channel messages and other things can be retrieved on the other channel. So this covers on the details of the parameterization, and this transparent port can be linked with the TCP port, and the tool, even though the tool only support a COM port, you can have a virtual COM port emulator there, and in that you will be given a virtual COM port for the tool to connect, and on the other end you can TCP channel, so IP can be given. So from, even though the tool uses COM port, the underlying channel will be going through the transparent system, and this transparent channel can be linked to a serial port or a TCP port, and this can be routed through this. So this is how the transparent channel works. So this covers majority of the question. So thank you for attending this, and giving the control back to Shreyas. Shreyas, please.
Thanks, Fred, for your presentation, and thank you all for joining us today. Please check out our other upcoming webinars we will be hosting on our website. Thanks so much for your time. Have a good day. Thank you.